Okay, we're going to go through the Geometry 4-8 shadow test. Exact trig values first. Watch the Maths Watch clip if you can't remember how to do these. There's a neat trick. You can use your hand to help you remember these things, but you just need to know them. So cos 60, let's start with that first. That is just equal to 1/2, or 0.5. Tan 30 is equal to the square root of 1/3, which would be fine for this. You'd get the mark for that. Since this is testing your knowledge of exact trig values rather than surds. But if we want to write that properly, this is the same as the square root of 1 over the square root of 3. Square root of 1 is 1. And that is something with an irrational denominator. So if we rationalise the denominator, we would end up with root 3 over 3. That's the best answer. Sine 60 is root 3 over 2. And we've got a little addition here, we've got to do it twice basically. Tan 45 is 1, and sine of 0 is 0, so this gives us 1 when we add those together. Okay, question 2 is also assessing your knowledge of exact trig values, just in an applied context. Note here that we have a right angle triangle, that's key to the question. It's going to be something to do with Pythagoras or trigonometry. Let's have a look. Find the length AB. Now, given that we've only got one length of the right angle triangle, this can't be Pythagoras. We've also been given angles, so it's definitely trigonometry. Right, so let's think about this. How are we going to find AB? We have the hypotenuse of the larger triangle, we have an angle, and we want the opposite, basically. Okay, so if we've got hypotenuse and opposite, that's going to be the sine ratio. Okay, if we want to find the opposite, we do sine of the angle multiplied by the hypotenuse. So we're going to do sine 30, since we're looking at the overall larger triangle, times by 2 root 3. Sine 30 we know is a half. Half of 2 root 3 is just root 3. Okay, find the length CD, so this length here, and give your answer as a surd. So let's have a look. We're going to have to use the smaller triangle here as well. So now that we know this is root 3, we could use Pythagoras to find this bottom length, or we could use trigonometry. It doesn't really matter. I'm just trying to think if there's a quicker way. Let's use trigonometry. So here we've got the adjacent side. I'll tell you what, let's just focus on the smaller triangle first. So we'll just find this length here from B to C, which is still adjacent. We've got the opposite, we want the adjacent. Opposite and adjacent is the tan ratio. Okay, so if we want the adjacent, we're going to do opposite divided by tan of the angle. So we're going to do root 3 divided by tan 45. Tan 45 is 1, you see that up here, so this is root 3 as well. So BC is root 3. So write that down so we remember what we just worked out. And we need the overall length so that we can take that away from it. Okay, so again, we could use Pythagoras or trigonometry here. Let's go with trigonometry. This time we're looking at the larger triangle, so the 30-degree angle. So we're going to do opposite divided by tan 30 this time. So that's root 3 divided by tan 30 is root 3 over 3. Now when you divide fractions, it's the same as multiplying by the reciprocal. So the reciprocal of this is 3 over root 3. And when we multiply those together, these are going to cancel each other out. So we're just left with 3. So the overall length BD is 3. So if we want just CD, we're going to do 3 take away root 3. And that's the final answer. Don't be worried here that we don't seem to have anything in front of the root 3. That just means that our value of B was 1. And actually, don't be worried also that it appears to be a positive number here. All that means is that our value of B is -1. Okay.